Chapter number 11, three-dimensional geometry. Our board has this chapter, term 1, and CBSE will be next one. Taking recording, upload on YouTube so you can revise later. My goal is to finish this chapter in 6 classes. Let's see how far I can go. And let's start the chapter. To understand this chapter, one must understand the previous chapter, that is vector algebra. If you understood that chapter properly, into that too particularly direction cosines. Okay, 11.1 is all about if you understood direction cosines properly. So what we learned actually. So thoda explanation part before the exercise. Let's get ready. Direction cosine. Of a line. So just check the diagram and understand properly. And whenever I'll start writing, and you can write also. But I'll tell you to draw the diagram also, but not now. Please wait. So we are revising. This is the origin. This is the origin. And suppose you have some point P. No need to draw this one. This is only for explanation. If you have some point P in the space, matlab in 3 dimension, that means I used to explain in the room. When you remember in physics during the 11th standard physics, I used to say that if you are sitting in a room, then what is the location of your head? So you can describe with the help of x-axis, y-axis, and z-axis respectively. And in that case, you might get all the measurements of regarding any other points also. Okay, and this is making, suppose this one is x-axis, y-axis, and z-axis. So whenever any point P is located, P is called as position vector. And in the previous chapter we learned, okay, this vector you can see that it is starting from the point origin O. Okay, and it can end up to infinity, right? But we are taking one point OP. It's an arrow, so you can extend up to infinity, but we are talking about one point P. So that means this line at any other distance, okay, at any other distance. Suppose this is a line. Okay, suppose this is a line at any distance. So this line can make some angle with x-axis, and we used to say that this angle is alpha. With y-axis, it makes beta, and with z-axis, it makes gamma. Right? So alpha, beta, and gamma are called direction angles. We used to say alpha, beta, and gamma are direction angles. And cos alpha, cos beta, and cos gamma are called direction cosines. If you remember. Just take direction angles, matlab or angle between the x-axis and the particular position vector. Okay, that's it. That is alpha, beta also with y-axis, gamma is what with z-axis. So direction cosines, matlab cos alpha, cos beta, and cos. With the help of geometry, one can find easily that by this cos alpha can be if I can write as L. Cos beta if I can write with M, and cos gamma if I can write with N. So this L, M, and N are also called cosines, direction cosines. Cos alpha, cos beta, and cos gamma are direction cosines. So this L, M, and N are known as direction cosines for this position vector OP. This much we had learned. Let's now go forward. To this, not required to write anything. This was like a revision part. We require to understand this alpha, beta, and gamma and all things. So now we are starting. You must give the heading, same heading, direction, cosines of a line. Now the chapter starts. Again, draw three dimension, X, Y, and Z. Suppose sometime it happens that my line is not passing through the origin. Suppose some line AB is not passing through the origin. So how can I make alpha, beta, and gamma? In this case, we can draw any other line which is parallel to AB but passing through the origin. Let's try to draw in such a way so that it will pass through the origin. And this line, suppose if I would say L is the line and this is the origin. In this case, our x-axis makes alpha with L, y-axis makes beta with this L, and z-axis makes gamma with L. So if some line is not passing through the origin, we would draw any other line which is parallel to AB but passing through origin. And then we will find out alpha, beta, and gamma. So a line L passing through origin O and parallel to line AB in space. In space, matlab in X, Y, Z, three dimensional only. Let alpha, beta, and gamma be angles made by line L, which we already wrote in the diagram, and let alpha, beta, and gamma be angles made by line with X, Y, and Z respectively. Then cos alpha, cos beta, and cos gamma are called direction cosines of line AB. Direction cosines of line AB. The direction cosines are denoted by, how we denote, LM and N? L, M, and N. That case, L is equal to cos alpha, direction cosines, right? L, M, and N are direction cosines. Matlab cos alpha, cos beta, and cos alpha. Cos. Give another heading. Direction ratio.
Ma'am, can you please go back to the... Thank you, ma'am.
Take a screenshot otherwise. that case we go further because I want to complete exercise. One exercise is very small. Can do it today. Very small. It will take hardly 15, 20 minutes. Exercise and explanation. 20 minutes. Direction ratios of a line. Direction ratios of a line. Now, once we have learned, already we learned okay, by what are direction cosines, right? So what are new terms? These are new terms, right? The direction cosines of a line. So what is it? So you know what? Any, just write down and I'll explain. Any three numbers which are proportional to the direction cosines of a line. Any three numbers which are in proportion. That means if we take ratio of L, M, and N with any some three numbers. So these ratios are going to be the same of a line are called the direction ratios of a line. Direction ratios. Let's understand in detail. Okay, if L, M, and N are direction cosines. If L, M, N are direction cosines. And A, B, and C, small a, and A, B, C are direction ratios. Direction ratios of a line. Then this A is equal to lambda n. A is equal to lambda n. B is equal to lambda n. And C is equal to lambda n. You can see we got three ratios. They are called the direction ratios. We will be having three numbers with direction cosines. See, L, M, and N are direction cosines. If we have three numbers, so that their ratios are going to be the same. In this case, you can see A is equal to lambda L. So A is equal to lambda L. So it is like 1 by lambda. Okay. Lambda is any constant. See, constant lambda. Suppose I can put only K instead of 1 by. It's just we are saying that they are going to be in same ratio. Matlab they are in proportion. Is equal to lambda L, B is equal to lambda M, and C is equal to lambda N. So A, B, C are called as direction ratios. The direction ratio. Understand properly. Direction cosines are L, M, and N. We are going to have three numbers such that their ratios are going to be same. Their ratio matlab corresponding cosine, direction cosine matlab x axis के साथ x axis वाला मतलब L by A, M by B, N by C. All these are going to be the same. Okay. Sometimes we are in need of finding all this. It's very simple thing. I will do in numerical and you will find it easy. But then yes, theory part, as you know, theory part always makes us confused, and then the exercise comes. For any non-zero, because 1 by lambda, no, it should be non-zero lambda, which is let ABC be direction ratios of a line and let L, M, and N be the direction cosines. Sometimes we say DC only, right? Direction cosines of the line, of the line. Line matlab some line is passing through the origin and all alpha, beta, and gamma, in x, y, z, x is just so cos alpha is L, cos beta is L. That we can find out L, M, N, C. Maybe see our direction ratios, L, M, N are direction cosines. In that case, L by E, M by B, and N by C. All these are going to be the same. A constant. Going to be the same for L, M, N, C. Okay. In that case, one can write L is equal to AK. If you compare the first one with K, you can find out L is equal to AK. If you are comparing second one with K, M is equal to BK, and you can compare your N by CK also with K. N is equal to C. L is equal to AK, M, BK, and N, CK. But we know one thing, we know one relation with L, M, and N. What is that relation? Last previous step, we have already learned. L square plus N square plus N square is equal to 1. This we have already learned. But this is known. Let me substitute all the values. So x is AK square plus BK square plus CK square is equal to 1. A square is common. It's A square plus B square plus C square is equal to 1. So if this is so, we can find out value of K. Constant K value will be. So if we ever in need of finding that constant, we can find out, and we can take square root also, right? So it's plus or minus. Once we take square root, it will be 1 by it goes to the denominator, A square plus B square. And once we know K key value, once we know K, I can find out L, M, and N. I can substitute in above value of K. I can substitute here and I'll get all L, M, and N. Matlab direction cosines can be found with the help of direction ratios. That means L is equal to plus or minus A upon into K, that means 1 by plus or minus 1 by under root of A square plus this. Then M is equal to plus or minus B by B square plus B square plus C square. And N is equal to plus or minus C by under root of B square plus B square. So this was very important. In part completed. Hardly we are going to see 2 more parts and then we will start. The third one is also similar. Let's start the third one. Relation between the direction cosines of a line. Suppose we have a diagram. Let's draw a diagram. X, Y, and Z. Suppose we have a line. थोड़ा ज़्यादा because it looks like X का parallel. Let me draw that way. So it's AB. Suppose this one is AB, and parallel to that, passing through the origin, a line OP is there. is the line, so it makes alpha, beta, and gamma. We can find out if it is passing through the origin. If you do not, if it does not seem that these two are parallel lines, please you people draw like they are in parallel. So P is like, suppose one point P is having coordinates in 3-dimension X, Y, Z. And in that case, suppose I want to find out value of X. If I want to find out value of X, okay, in terms of direction cosines, then I had taken perpendicular, like we did this some kind of thing in this 10th chapter also, like algebra. Let's suppose I took from P to x-axis, I drew one perpendicular. Okay, here it is perpendicular. This one is 90 degrees. If we do not see it properly, suppose I'll write R over here. Let me draw a right angle triangle. What is it actually? So you can see where is the origin. This is your origin. This one is OP. Okay, and we drew on x-axis. We drew perpendicular, and that is R. So actually, we are making somewhat like this kind of. It does not seem like that, but just imagine. Try to imagine that you are in a XYZ 3-dimensional room, and from one point you can take perpendicular on the x-axis. You can take perpendicular line on the x. That means you are having a triangle with the x-axis. Okay, right angle triangle. And what is your alpha? What is your angle? Alpha. So as you know, you make alpha with x-axis. That means this is your x-axis, right? इतना काट रहा है. This distance, यहाँ से लेके origin तक your x-axis, and यहाँ से लेके ये P तक, this is your R. OP vector is R, so this is R, right? And our interest is to find X in terms of alpha, direction. Try to understand this diagram. Okay? Here you are going to use trigonometry. Little bit. So from the diagram, you can see cos alpha is equal to adjacent side OR by hypotenuse, that is OP. OR is X and OP is R. So that means X is equal to R cos. Similarly, one can draw perpendicular on y-axis and z-axis, right? And we can find out. Similarly, acha, here cos alpha we can write as L also, no? By the way, it's X is equal to RL or LR, whatever. LR. Similarly, we'll be having Y is equal to R M and Z is equal to R N, right? But we already have L square plus N square plus N square, right? That we have, relation we have, right? And one more thing one should remember, okay? Okay, in rough, I would like to tell you, whenever we were in need of, suppose you have a vector R, suppose you have a vector R, OP, okay? So we used to say, okay, it is OP is R, so magnitude of R, that is OP, or we used to say R also, that is under root of, suppose P coordinates are X, Y, and Z, then R we used to say it's under root of X square plus Y square plus Z square, which is magnitude of OP vector, okay? Which is magnitude of vector OP. So this is the way we used to do. So we can utilize here, right? We already know this. We know that X square plus Y square plus Z square is equal to R square, right? We know this. But here, so we found X is equal to RL, Y is equal to RM, and Z is equal to RL. Let's substitute it. RL square plus RN square plus Rn square, which is equal to R square. So it's R square common. In this case, R square plus M square, L square plus M square is equal to R square. All right. In that case, we can prove that yes, it is the relation. The previous chapter, we did not have proof of how come L square plus M square plus N square is equal to 1. But this is the proof of this by sum of the square of direction cosine is equal to 1. Relation between direction cosine, what is the relation? Which is L square plus. How it came? Try to understand this. If you forget, then also it's fine. But if you have descriptive paper, they can ask in different way also. The proof and all these things. So remember what we had. We had some line AB, but this line AB could not make alpha, beta, and gamma with x-axis because it is not passing through origin O. So we took one more parallel line, which is parallel to AB. And then we can assume that alpha, beta, gamma are three angles, which is made with the x, y, and z axis. And P is the coordinate, P is having coordinates x, y, z. And in that case, we drew this. Okay, from P, if I draw perpendicular on x-axis, we will be having this kind of triangle. And if we have this kind of triangle, then cos alpha is equal to adjacent side OR by OP. From that, we found x, similarly y and z. We know the relation by magnitude of any vector is equal to under root of x square plus y, and that we used and substituted, and we proved that. That is the thing. Let's go to the last topic, and it is very important. This is very important. If you do not understand it, by the way, it's very simple. Very easy to understand also. If you read the book for this chapter, so vector algebra, if you just go through the book, textbook NCERT, you will find it easy. But if you read this chapter, if you go through by this chapter in NCERT, you are going to be lost. Please don't read the chapter. The teacher would say like this, but you will become more confused. Okay, so for this particular chapter, I want to go through the text. Chapters are like that. Mention it is showing so many diagrams. Children can get confused like that. What is the theory we are going to see? Direction cosines of a line passing through 2 points. Passing through 2 points. As of now, we used to say 2 points only, no? It's like AB and OP and all, but this O is the origin. P is only 1 point. Suppose now you have 2 points. Okay. Suppose you have a line which is made up of 2 points, P and Q. P and Q. Then what will be the direction cosines? So as we know, we'll discuss about only z axis. Only z axis का discussion करेंगे, फिर similarly कर लेंगे पूरा. So if this is z axis, parallel to z axis will be somewhat like this. Parallel to. If PQ makes a gamma angle with z axis, that means इसके साथ भी gamma ही बनेगा. Right? If this is so, let me make xy plane. What is xy plane? Let me tell you. If this is x, y, and z, no. This plane is called as yz plane. Then this plane is called xz plane. And the down part, this plane is called xy. So here from point P, if I need to draw a perpendicular point on xy plane, so it can be somewhat perpendicular at R, and from here also I drew, and which is at suppose S points we got perpendicular on xy. This is the perpendicular points on xy. Let's write along. Let L, M, and N be the direction cosines of the line PQ, and we are going to have some angles with x-axis, y-axis, and z-axis, suppose alpha, beta, and now, and let it makes angles alpha, beta, and gamma with x, y, and z axis respectively. I need to draw one more perpendicular. That means I'm going to draw from P to, suppose I'll say N. So draw PN perpendicular to. As I drew perpendicular, if this is gamma, you can see it makes Z with parallel lines. If these two lines are parallel, then they are making alternate angles. So whatever angle is here, that same angle will be over here. In this case, this is gamma. So this is gamma. So I can find out cos gamma. Cos gamma is equal to adjacent side Qn upon hypotenuse in that triangle. Which triangle are we taking? We are talking about the triangle PQN. Qn by hypotenuse is PQ, right? That means Qn. As we have already drawn from Q to XY plane perpendicular, right? That means X and Y coordinates of points Q and N are same. X and Y coordinates are same. That means which coordinates are different? Z coordinates are different, right? Suppose Q are having X2, Y2, Z2, and P Q and N is having X1, Y1, Z1. In that case, X1, X2, Y1, Y2 will be the same because they are perpendicular to that plane. So here, what are the difference then? Q and difference kya rahega? Z2 minus Z1. Okay. Because since you can see over here, it is difference in Z axis only. X and Y are with Z2 minus Z1 upon P. So if we can draw like this, Pn perpendicular to Qn, we can draw in different plane also. In XZ plane for Y-axis, I can draw perpendicular to YZ plane for X-axis. We are not going to draw everything. Just wanted to prove for Z-axis. Now we can write down similarly, cos alpha is equal to x2 minus x1 by PQ, and cos beta is equal to y2 minus y2. This is important. Huh? If you have 2 points on a line, your direction cosines will be found in different. You have only one point P and origin. So फिर simple है. That manner only. like we did in the previous chapter also. A by R, B by R, otherwise A1 by R, A2 by R. If your vector is R, X, Y, Z, then X by R, Y by R, Z by R, direction cosines. If you have only one point P, if you have 2 points PQ, then you have to do X2 minus X1, Y2 minus Z2 minus, where coordinates of P is X1, Y1, Z1 and Q for the direction cosines. In that case, direction cosines of the closing statement, the line segment joining points P, X1, Y1, Z1 and Q, X2, Y2, Z2 are direction cosine. कैसे लिखेंगे? Direction cosine is alpha, beta and gamma. What is alpha? X2 minus X1 by PQ. And cos beta is Y2 minus Y1 is PQ. And Z2 minus Z1 is, what is PQ? But how we find PQ? If you have vector R, not simply we used to write x square under root of x square plus y square plus z. But we have PQ. How do we have to find? We have to similar manner. If you remember this chapter, we used to find the distance and all. Formula only. PQ is x2 minus x1 square. If you have 2 points, you'll be using this one. If you ever have 1 point, then you will use the number. This chapter will be having 2 points. So that's it. One last note. Remember, sometimes this direction ratios are mentioned as direction numbers. If you have JE and all, no, you can write in the छत पे लिखना बोलते हैं on top of the book में. Imagine direction ratios are same as direction numbers. The textbook it is given as direction ratios. Exams or anywhere, if you find direction numbers, consider as ABC direction ratio. Direction is ABC. A, comma, B, commas. How we found this direction cosines with the help of ABC. What are these ABC? ABC are those ratios which are in proportion. Note. The direction ratios of the line segment. What is the direction ratios? So we had only, if you remember, direction ratio हमने ABC लिखा. ABC are direction ratios. But here we have 2 points. For a line segment, we have 2 points, P and Q. How do we write? Line segment joining will be x2 minus x, simple है. Y2 minus y1, z2 minus z1, or one more thing, both are correct. Okay, don't compare your answer with your friends. X1 minus x2. If your answers are in negative, then your friend, then also your answer will be correct. Don't worry. He or she must have done different way subtraction. Okay, but both ways correct. Okay. NCERT mentioned it, so don't worry about some teacher would do like that. You can show that NCERT. exercise. That's 11.1. Question 1. If I do not explain, then also you will be able to solve this. If a line makes angle 90 degree, 135 degree, and 45 degrees with the x, y, and z axis respectively. So we know, okay, whenever some angle is made with line and x, y, z, these are nothing but alpha, beta, and gamma, right? These are nothing but alpha, beta, and gamma. What do we have to find? Find its direction cosines. So it's L is equal to cos alpha, right? So it's cos 90. L, M, and N are direction cosines. Cos 90 is 0. M is cos beta. Cos 135. We don't know what is cos 135. The 0 you have. This is pi by 2. That means it's 90 degree, and here it will be like 180 degree. Cos 135 matlab here somewhere. We do not have any answer, but we can write like 135. We can go from like this 180 minus. So how close to 185 with 180 with this? It's 45 degrees. So in place of 135, I can write 180 minus 45. It's nothing but 135 only, right? Right, in this manner. It's cos 180. Okay, cos 180. That means 180 minus. That means we are talking about second quadrant. In second quadrant, cos becomes negative, and cos 180. That means cos will remain cos. It's cos 40. Now, one of you would say that I don't want to take 135 as 180 minus 45. Fine, you can take 135 as like 90 plus 45 also. Okay. But when cos 90 plus 45, cos 90, but it is second quadrant, again cos becomes negative in second. All S, silver, okay, silver, sign positive, cos negative, minus, but 90 degrees there, the cos turn to sine, and 45 is the sine 45, cos 45, both will give us same answer, which is minus 1 by 2. Whether you can use that. I just revised because okay, it all cos alpha, cos beta, cos gamma, cos 45 degrees, which is 1 by. So these are like direction cosines. Some direction cosines of the line are 0, minus 1 by 2, 1 by. In question, find the direction cosines of a line which makes equal angles with the coordinate x. Find the direction cosines. What do we have to find? L, M, N, which makes equal angles with coordinate. Equal angles, okay, given what is given? What is given? Equal angles they make. Alpha, beta, and gamma are equal. In that case, cos alpha, cos beta, and cos gamma are equal. We know one relation of them, cos all three. Yeah, since we know this, like cos square alpha plus cos square beta plus cos square gamma is equal to 1. If you forgot, remember it came from this. L square plus m square plus n square is equal to 1. What is L? Cos alpha, m cos beta, and the L is cos gamma. So in that case, we know this relation. Let's substitute everyone in the one context only. So cos square alpha will keep cos square alpha, cos square beta is cos square alpha, again cos square alpha, which is equal to 1. It's 3 cos square alpha is equal to 1. So it's cos alpha is equal to plus or minus 1 by root 3. All three are same, cos alpha, cos alpha, cos alpha only. That means direction cosines of a line is plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus. You people are going to find this answer. The alpha, cos beta, and cos. Question. If a line has the direction ratios, mind well, what are these ratios? A, B, and C. A is minus 18, B is 12, C is minus 4. What are direction cosine? Direction cosines, matlab L, M, and N. And we already this relation saw that. Okay, by direction cosines, and those L is equal to plus or minus A upon the root of A square plus B square plus C square. Just solve. For M, it is plus or minus B by. Right? For N is equal to plus or minus C by. Same denominator. Let's do it. And find it is like fun. Denominators are same. Plus or minus. Then again minus. Acha, whenever we substitute in the formula, we do not consider. It can be positive or negative. It was just showing that we are not going to use it. So it's minus 18 square plus 12 square plus minus 4 square. It's minus 18 on 324 plus 144 plus 16 addition. It's 156 D and again it's 484, which is 22, right? Square of that minus 9 by 11. M E by similar things. Answer box, direction cosines. That was the third question. Very simple. More questions? Show that the points are linear, co-linear, straight lines. If they are co-linear, how can we check? How can we prove using this step? So in that case, their direction, if we have 2 points, they are collinear, right? If we have 2 points, suppose A, B, and C. If we take 2 points, we can find out direction cosine. Correct? If direction cosine of AB and CA or BC, they are in proportion, we can say that they are collinear. They are in proportion. Simple, because it is making alpha, beta, and gamma with x, y, and z axis. If they are in proportion, then we can say they are in the same line, right? Then only, because once the angle is like somewhat like this, suppose we have a B and a Q and R also. So they will make same angle, whether whatever you take, y axis is at same angle. Even with the x axis also, it makes the same angle for z axis, but they will be in proportion. We can check with the direction ratios in that case. Direction ratios are in proportion, we can see. It's easier, just see it, find it. Let points are giving the name here. A, 2, 3, 4, B -1, -2, 1, and C 5, 8, 6. We know that direction cosines of points. How do we find direction cosines of points x1, y1, z1 and x2, y2, z2? How we find direction cosines? So at the end of the note, if you see direction cosines are nothing but x2 minus x1, y2 minus y1, and z2 minus z. These are direction cosines. These are direction cosines. So let us find out direction ratios. How? So direction ratios of AB. How we'll find for these 2 points? We found x2 minus x1, and we wrote by x1 minus x2 is also 5. But we always take, like, if it is AB, we'll take coordinates of B, x coordinate of B minus x coordinate of A. So B may, what is the x coordinate of this? It is -1. We are finding for AB. So it's -1, -2. Then for y, it is like -2, -3. And for z, it's 1, -2. So that way we can find out direction ratios. We used to write ABC and all. So that's it. -1, -2, -2, -3, 1, -2. That means they are -3, -4, and -3. So these are direction ratios of AB. We can find out for BC or we can find out for AC. Okay, they will be in proportion. We'll see the direction ratios of BC. Matlab C coordinate minus B coordinate corresponding with X. It's 5 minus -1, it's +2. 8 minus -2, +2. 7 minus 1. So it's 6, 10, 6. So you can see they are in proportion. The answers we found by this, it is -3, -5, -3. You can see 6. 10 and 6. If you multiply -3 with -2, -3 by -3 by -2, you are getting 6. If you're multiplying -5 with -2, you're getting 10. And if you're multiplying -2 with -6, so again you're getting this only. Right? So that means they are in proportion. If you're multiplying with a constant, some constant, then you're getting again this another direction to ratio. That means they are in proportion. If they are in proportion, we can say that AB and BC are collinear. That means they are in the same line. They are on the same line. A, B, and C are on the same line. They are collinear. It can be seen that the direction ratios of BC are -2 times direction ratios of A. That is, they are in proportion. That means AB is parallel to BC. When two direction ratios are in proportion, we can say they are in parallel. For this case, AB and BC, they are in parallel. So A, B, and C in line only, because B is the same number. Same point. AB is parallel to BC. Since point B is common to both AB and BC, points A, B, and C are collinear. Find the direction cosines of the side of the triangle whose vertices are this. You can see direction cosine we used to find for with origin 1 point, or we can find out for 2 points. Here we have 3 points, A, B, and C. So how many lines do we have? Since it is a triangle, we have 3 lines. So AB, BC, and CA. For all 3 lines, we are going to find out direction cosines. It will be like L, M, and N. We are finding for all 3. How do we find out L, M, and N? It is like A upon under root of this. Right? We can find out if we have ratio. Otherwise, we can find X by R, Y by R, Z by R. But very simple. Let A 3, 5, and -2, B -1, 1, and 2, and C -5, -5, and -2. These 3 are vertices of a triangle. These are vertices, but we can find out direction cosines for line or line segment. AB, BC, CA. We have to find out AB, BC, and CA, right? So let us find out first of all ratio, this direction ratios. The direction, once we have A, B, and C will be easier. We can use direct formula. if we have A, direction ratio for a first line, we can find out. For A, how do we find out A? So it's like x2 minus x1. That means if you're finding for AB, coordinate of B minus coordinate of A, for x-axis, y-axis, z-axis. So these are your direction ratios, which are A, B, and C. And then we can substitute in the L, M, and N. We have to find out 3 times. So it will be like L1, M1, N1, L2, M2, N2, L3, M3, N3. We have to find out for all of them. And this is the last question, which is lengthy, but it's very simple now, by the way. चलिए start करते हैं, लंबा जाएगा. The direction ratios of the side AB. So it's like B coordinates of B minus A. So it's like -1 minus 3, 1 minus 5, 2 minus minus 4, it's plus 4. So it's -4, -4. So these are our A, B, and C. You are going to consider this as A, B, and let's find out L1, M1, N1, which are direction cosine of line AB. Direction, because see, you have X, Y, and Z axis. Right? Now you suppose you have a triangle. All lines A, B, and C, all are making different angles. AB will make some different angle with x-axis, y-axis, z-axis. Then BC will make some other angle with x, y, and z. AC will make some other angle, right? So we have to find out all cos alpha, cos beta, cos gamma. We do not have angles. How do we find? If we have direction ratios, this is the formula. So we are using this one. Don't need to draw this right. L1 is equal to, I'm not writing the formula as I have mentioned over here. We are going to utilize it. A matlab -4 under root of -4 square plus -4 square plus 6. So, and for, let's do it long process. M1 E same thing. N1 C upon direction cosines of line AB. Let's do direction cosines of side BC, but for that we have to find out direction ratios. For that, let's check. BC, matlab coordinate of C minus B, it's -5 minus +1. -5 -1 -2 -2. With the help of this, we are considering these ratios as A, B, and C. Let's find direction signs L2, M2, N2, L2. Denominators are same, -4 minus 4, 6, 4, same thing, 68, and everything will be this. Similarly, we'll find for CA. First of all, direction ratios. Right, CA, the coordinates of A minus C, A minus C, 3 pi minus 4, B by E, it's -5 minus 5 minus 2, 5, 5, so -5. Plus, anyway, 8, 10, the ABC, consider as ABC, we are finding direction cosines of side CA, L3, 8 upon 8 square, 10 square, minus 2 square, 8 upon 168. Check it is. तो कुछ आएगा ही नहीं. It's 40. 4 by M3, 10. Pi by under root. Right, final answer. We bracket like this, then also it's fine. Sides of sides of the triangle.
minus.
minus. And we completed exercise 11.